Hello everyone, this is Dnyaneshwar Sanap, working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarak Samaj, Arts, Commerce and Science College, Dindori. In today's video lecture, we will discuss about the molecular orbital energy level diagram for H2 plus molecule. Let us explore the one by one. Basically, H2 plus molecule is made up of one hydrogen atom having single electron and other hydrogen atom having positive charge. Let us see the electronic configuration for each. The electronic configuration for first hydrogen atom is 1s2 and electronic configuration for second hydrogen atom which having positive charge is 1s2 For H2 plus molecule, one of the hydrogen does not having electrons in its valence shell. Then we get the H2 plus ion. The tabulated form of electronic configuration is like that: 1s2 1 electron and 1s2 0 electron. The total number of electrons participated during the formation of molecule is 1 electron. As we discussed in the previous videos, let us start the drawing of actual molecular orbital energy level diagram. The increasing order of energy level of atomic orbital is like that, and the energy of each atomic orbital is at the same horizontal point as like this. The atomic orbital for hydrogen first, which having the 1 electron, and this one is the atomic orbital of hydrogen which is in the H plus form, that means no electron in its valence shell. When these two atomic orbitals are combined together, then according to the linear combination of atomic orbital principle, that is LCO principle, the two molecular orbital is formed. That means when two atomic orbital combines, they gives the two molecular orbital. Out of these two molecular orbital, one is lower in energy, that is called as bonding molecular orbital, and one is higher in energy, called as anti-bonding molecular orbital. The lower energy bonding molecular orbital is denoted by sigma 1s, and higher energy antibonding molecular orbital is denoted by sigma star 1s. This decreasing in energy in bonding molecular orbital is balanced by the increasing in energy by antibonding molecular orbital during the formation of molecular orbital. Whatever energy decreases during the formation of molecular orbital, that is bonding molecular orbital, called as stabilization energy. Similarly, whatever increasing of energy in the molecular orbital because of formation of antibonding molecular orbital, called as destabilization energy, or this antibonding molecular orbital destabilize the molecule. The next point is filling of electron in molecular orbitals. According to the above principle, the filling of electron from lower energy toward the higher energy. In H2 plus molecule, there is only one electron involved in the bond formation, and that's why the first electron or this one electron comes to the lower energy bonding molecular orbital, and there is no second electron to put in the bonding or antibonding molecular orbital. From this diagram, we carry forward to the writing of electronic configuration for H2 plus molecular orbital diagram. The electronic configuration for H2 plus molecule is sigma 1s2 and sigma star 1s2 because of there is only one electron which is present in the bonding molecular orbital, that is sigma 1s orbital, and there is no electron in antibonding molecular orbital, that is sigma star 1s. That's why we write the electronic configuration for H2 molecule is sigma 1s2 and sigma star 1s2. Next point is calculation of energy evolved during the formation of H2 plus molecule. The energy evolved during the formation of molecule is calculated by using the formula number of electron in the bonding molecular orbital into minus beta plus the number of electron in antibonding molecular orbital plus beta. As we know that the only one electron which is present in the bonding molecular orbital, and we put this value in the formula, we get the result like that: 1 into minus beta plus 0 into plus beta, and result of this we get the minus beta as an stabilization energy. That means the molecule is formed in some extent. Next point is calculation of bond order. The bond order is calculated by using the formula: the number of electron in bonding molecular orbital minus the number of electron in antibonding molecular orbital divided by 2. Put this value of number of electron in bonding molecular orbital and antibonding molecular orbital, we get this one: 1 minus 0 divided by 2. Finally, we get the 1/2 value. This 1/2 value indicates that there is formation of bond. That means the molecule is formed in somewhat stability. It not formed as like H2 molecule. Next point is magnetic property. H2 plus molecule having only one electron in the bonding molecular orbital at lower energy, and this one electron is single unpaired electron. That's why the molecule is paramagnetic in nature. When we compare this molecule with H2 molecule, then the magnetic nature of both molecules are different. H2 molecule having 2 electrons in its bonding molecular orbital, which we see in the last video. But H2 plus molecule having only 1 electron in its bonding molecular orbital. That's why the H2 plus molecule is paramagnetic in nature. In next video, we will discuss about the He2 molecule. Thank you. Thank you for watching.